So we'll start with the pop quiz 13 discussion, which was mainly related to force in extension. In the first part of a question, state two features of a vector quantity. A force is a vector quantity. Like, what are the features of the vector quantity? The vector quantities have direction and they will have magnitude. Magnitude means like value or a size will be there and a direction is also there. That is refers to a vector quantity. State name of two other quantities that are vector. Other than the force, we have to give two examples or two quantities which are vector quantities of what we can mention. We can mention velocity, weight, momentum, impulse, or acceleration. A lot of examples are there. So you can mention velocity. Speed is wrong because speed is a scalar quantity. So you can mention velocity or you can also mention acceleration or momentum or impulse, weight of an object. These two are the vectors. In the second part, a student suspended a spring from a clamp, as you can see here, and he measured the length L0, the spring as shown. Figure 2.1 shows an apparatus, as you can see, which is not to scale. The student that suspend L0 means like length of a spring without any load. Nothing is connected to this, and then we measure the length, we call that as L0. That is the length of unloaded spring. The student then suspended loads of different weights on a spring and he measured the length of each length of a spring for each load, and then he plot a graph for the length of a spring against the weight. So one thing, if a graph is there between a length and the force, so the graph will not start from origin. Because without any load, there will be some length. So if you have a length and load graph, length is their example in centimeter, load is their Newton. So this graph will not start from origin, it will start above origin. But if the same graph was there between force and extension or load and extension, on x-axis if we have load and on y-axis if we have extension, in that case, because load or extension or force and extension, they are directly proportional, so there must be a straight line which is passing through or starting from origin. So the student plots the result as you can see on the graph. Use a figure, determine the initial length L0 of a spring. What is the meaning of L0 or initial length? L0 or initial length is the length of a spring without any load, when the load is 0. So when the load is 0, we draw a line from when load is 0. So what is this length? This is actually L0. So 10 boxes equals to 0.2. So each box is equals to 0.02. So this will be 0.02, 0.04, 0.06, 0.08, 0.1 will be there, and it will be 0.12. So this L0, according to the graph, should be equals to 0.12 meter. Because the length is given in meter, that's why the unit is in meter. Is it clear, this one?
Yes, it's clear.
Okay. Then in the next part, state what is meant by the limit of proportionality, and figure 2.2 determines the weight of a load that causes a spring to reach its limit of proportionality. So what is the definition of a limit of proportionality? Limit of proportionality means like it is a point after which the extension is not directly proportional to load, or the increase in extension and increase in load will not be constant. So limit of proportionality is a point where the extension stop being directly proportional to load. You can also say, or beyond, it's a point beyond which extension is not directly proportional to load. So when you increase for load, the extension will increase, but not with the same rate. And how we can find what load or what force the extension and load are not directly proportional. So the last point where the line is straight, like example, it appears that this is a point where the line is straight. After this point, it get curved. So means this is a point limit of proportionality. So what is a load when it crosses the limit of proportionality beyond which load? So if we draw this line from here, so 10 boxes equals to 2. So each box is representing 0.2. So this will be 10.2, 10.4, 10.6, and 10.8. So 10.8 Newton is a load after this, the limit of proportionality being crossed. So you can say 10.8 here. Then use figure 2.2, determine the spring constant. What is, and it's of 3 marks. How from the graph, the length and load graph, how we can work out the, if it was a full load and extension graph, we just take value of the load and we take the value of extension, and load divided by extension will get the value of a K, the spring constant. Spring constant is actually load or force divided by extension. So it's up to you. You can take any force, any value from it. For example, if you took a force 8. So when it is 8, what is the length of the spring? So original length of a spring was 0.12. That was the original length of a spring. And when the load of 8 Newton is attached, like if we say when nothing was attached to a spring, it was having a length of 0.12. When we add a load of 8, and it's up to you, any load you can take, it won't make difference to the answer. So how much is the length? This is 0.42, 0.44, 0.46. So this is 0.46. So this length equals to 0.46. But we need an extension. We need how much the length increases. So it has increased from 0.12 to 0.46. So what is the extension here? The extension is 0.46 minus 0.12. So this will be equals to 0.34. So we have the extension with that is equals to 0.34 meter. So when the load or the force is equals to 8, the extension is equals to 0.34. So 8 divided by 0.34, what's the answer? 8 divided by 0.34. So that is equals to 23.5. So this is 23.5 Newton per meter. So it's up to you. As I mentioned, any force you can take within the linear region and you will get the approximately the same answer. Is it clear how we worked out the spring constant from length and load graph? It was, if it was extension and load graph, we just take the value of the load and extension and we just divide them to get the spring constant. Anyone having a doubt in this? Okay, so this was the pop quiz, which was related to the force in extension, or we can also say Hooke's law.